Okay, in this video we're going to be talking about probability using area models. So let's go and get started. An area model is nothing more than something that looks like this big old rectangle. Okay, this is just another way to display information regarding probability. So, like for example, using this area model here, if I was to ask, what is the probability of flipping a coin? Well, if you remember anything about flipping a coin, if the probability for heads for flipping a coin, and I remember I'm writing with my mouse here, so it's going to be a little off, is 1 over 2. Okay, so what you would say is it would be 50%. Okay, now if I was going to translate this into an area model, let me change this. This would be heads, and this right here would be tails. All right, and so just simply, if the probability is 50% for heads, that means in my area model, the heads square, which is, you guys can see it, but I'm going to highlight this head square that I'm highlighting right here, should be 50% of the entire model. Okay. Once again, just another way to display information when it deals with probability. Okay. So moving on. So here I have a basic probability tree. Nothing too fancy about it. You just have A, B, A, B, C, A, B. Now what I'm going to do is I'm going to create an area model. Okay. And so I'm going to, and I like working with rectangles and squares. It just makes life a lot easier. Okay. And so what I'm going to do is I'm going to first divide up my area model, okay, by the number. First off, dealing with rows, it all depends on how many the first expansion of the tree. And so the first expansion, if you didn't know, was this right here. Okay, so I have two options here, which means I'm going to have two rows. All right, so the the first expansion, how many times you expanded, deals with how many rows you're going to have. And so I'm going to have two rows. So let me try to divide this up as equally as possible. All right, there we go. Now, the next thing is, how will these rows get cut up? Okay, because now these rows are going to be cut up into little pieces. And the way you determine whether or not you're going to cut them into little pieces is by your second expansion. Notice here that A now has three options. So I'm going to make this row A, and it's been cut into three equal pieces. And I'm going to try to make this as equal as possible. I'm probably not going to be successful, but I'm going to try. That looks pretty good. All right, and so I'm going to label this. This is going to be piece A. This is going to be piece B, piece C. Because remember, each option is now represented in each row, like so. Okay, moving on. Let's look at row B here. I'm going to label this second row, row B. Okay, now once again, row B is going to have two pieces to it because there's two options. And so once again, I'm going to try to divide this up as evenly as possible. There we go. And this would be A, and this right here would be B. And there you go. That's how easy it is. That's how you easily make a probability, or I'm sorry, an area model here. So let's try one more. Okay, in this example here, I've given you another tree, and now you have X, Y, Z. So what I'm going to do is I'm going to give you an opportunity to pause the video to create this area model. Okay, so pause the video, work out the area model, and then I'll come back and talk about it. So, all right, so pausing in 3, 2, 1, pause it. All right, so welcome back. Now, looking at this tree, looking at this area model, I already know I'm going to have two rows because of the fact that it's been divided up two times on the first expansion. So I'm going to have two rows. So, and for labeling purposes, this will be row A. This will be row B. Okay. Now, next one is going to be how many times will the rows be individually divided up? Well, if you look at the second expansion, you have 3. So that means everything is going to be split up in 3 pieces. And so this will be X piece, this will be Y piece, this will be Z piece. And then we are going to do the same thing for B here. And so I'm going to divide this up evenly in 3 pieces. Or I'm going to try my best to. Alright, so this down here is X, Y, Z. Alright, so that's how you create your area model. Now, let's actually talk about area, okay? Area is equal to length times width. I'll spell it right. There it is. When you're dealing with a rectangle, okay? And we are actually going to apply this type of principle to finding the area of each rectangle within the larger rectangle. So here's what I'm going to do. When you're trying to find area, now this is where things get a little confusing for students because you actually can decide what numbers you want to use for area. So if you wanted to say, hey, the entire length of this thing will be 6 units. Okay, now you might be asking, where'd you get the 6 units? I just made it up. Okay, and then the entire width of this, or height, or whatever we call it, we'll call this 4. All right. Once again, where'd you get that number? I made it up. Okay. Sometimes the problems will already have dimensions for you. Sometimes you're just going to have to find it or make it up on your own. All right. So if I was to use 4 and 6, that means this 4, this part will be here 2, this will be here 2, and then this would be 2, 2, 2, because remember this is 6 divided 3 ways, that's 2, 2, 2. Now what I'm going to do is I'm going to find the area for each little rectangle within, or actually it would be a square, inside my model here. So 2 times 2 is 4, my area is 4, my area is 4 here, my area is 4, my area is 4, 4, 4. There we go, pretty simple. The total area of this entire rectangle would be a grand total of 4 times 6, which is 24. All right. Now let's talk about probability. All right. So let me clean up the tree a little bit, just by getting rid of some of this stuff. If I was to ask you, based upon the tree, what is the probability of AY? All right. What is the probability of AY? Well, you know you have 6 total options. All right. So the probability of A and Y would be 1 over 6. All right. Hopefully you can figure that out without me explaining too much. Now, going into my area model, what is the probability of AY? All right. Well, I go into my chart and I'm thinking, okay, where is that AY square? Oh, here it is. It's right here. And I'm highlighting for you. So that is a 4. Because the square footage of this one square was 4 over a grand total of 24. So 4 over 24, and that reduces down to 1/6. Notice we have a match here, okay? And so let's say if I was to ask you another question, let's say if I was to say, hey, what is the probability of not AY? Let's say if I just said, what is the probability of X? Or actually, I'm just going to make, what is the probability of Y? Well, Y is right here in my tree. Y is right here. So it wouldn't be 2, or it wouldn't be 1 over 6. It would now be 2 over 6. All right. Now, going back into my tree, or I'm sorry, my area model here, I would then choose all my Y's, which is this part and this part here. And so I'm looking for what is the probability of Y. And so there's my Y. Notice I have a grand total of 8 square footage. So let me change this, and this will obviously change. This would be 8 here. This also would reduce down to 2 over 6. Notice once again we have a match. All right, and so that's area model. Let me know if you have any questions. Thanks for watching.